This video is the third in a series about importing GDS2 data into EZMod3D. Please make sure you watch the first two before. Now we will actually import the data into EZMod3D. So first we have to run the software, and then we have either to choose to import the GDS through the ImportGDS button or through File, Import GDS. In both cases we have to browse to select the GDS text file we wish to import, and we have to select the layout netlist we wish to import. At this point, either we have a text file and we can use it directly, or we don't and we have to create it. In this case we have no text file yet, so we will create it. To create the text file, we have to define a name for all the layers EZMod3D could find in the GDS file, define the bottom Z coordinate and the thickness of the layer, and define the material for each layer. For instance, layer 2 is known to be NWell, so we'll call it NWell. Layer 3 is active, let's name it like this. Layer 4 is N+, layer 5 is P+, layer 13 is poly, layer 16 is metal 1, and layers above have been created by Boolean operation in KLayout. 400 is active contacts, 500 is poly contacts, 600 is PWell, 700 is STI, and finally 800 is oxide. So for bottom layers, for a bottom coordinate of layers, for the NWell and PWell it's 0, and for these two layers thickness is 1000, unit has to be nanometers in that case. Above these two layers we find N+ and P+ that start at 1000 and that are just only 100 thick. And above these we have both STI and active. That have the same bottom coordinate and same thickness. Above these two layers we have the poly, which starts at 1450 and which is 200 thick. Above this one we have the poly contact, start at 1650 and that is 600 nanometers, while the contact on active of course starts on the top of active and is thicker by the thickness of the poly layer, and both end up at 2250. This is the coordinate where the metal one has to start, and this one is 530. And finally we have the oxide that starts on top of STI inactive, and that is 5 microns thick, and that's it. Now we have to define the materials. So for STI and oxide we will select silicon dioxide, and for the other materials that are only defining nets. Finally, the properties actually do not depend on the material properties. However, it's a good practice to define an actual material. So for instance, for the two contact layers, we will define it as tungsten, and all for the metal one, we will define its aluminium, for instance, and for all the other layers, we will select one of the silicon materials of an arbitrary conductivity, 10 in that case, but it doesn't matter at all. So now we are done with all these layers. We can generate the text file. We will overwrite the existing one, and finally we will define in which domain we wish to simulate. In that case, we will simulate in the capacitive domain, and we are ready to import. Now we can open the project. So when we open the project, we can see the 2D representation of the imported GDS. It looks exactly the same as it did in K-Layout, but in EZMod3D, which is a 3D tool, we have now a 3D representation, including the z-axis coordinates that we have just defined as a text file, and now we have a 3D view of our mom capacitor. Let's have a look at the ports. And in this section, we figure out that we get exactly the net names that were used, defined by labels in K-Layout. Net A, one of the two electrodes of our capacitor, B, the other one, the poly screen below the capacitor, the N-well below the poly, with metal connected surrounding all the stuff, and the substrate locating everywhere at the bottom of this. So we won't go further with this. Of course, we could simulate it and display the results, but here the goal was just to import the data and show how to define that. Just a comment about that. Next time we have to import GDS using the same technology. Of course, we can, during the GDS import, choose the text file we have just defined, and it's no longer necessary to fill in the data.